Okay, before we start the next lesson, let's go back and revisit solving inequalities that involve multiple steps. Okay, so in this warm-up, there are 3 questions here. I want you to go through and practice those solutions, and we'll come back. So go ahead and pause the video. We'll come back, and then we'll look at the answers and see how we did. Okay, so let's check your answers here. So the first one, you should get that t is less than 3. The second one, we should have t is greater than or equal to 7. And in the last one that involves the distributive property, you should get all real numbers, okay, meaning that both sides are always going to be true. They'll be the same, okay? So for the lesson today, we're going to deal with what are called compound inequalities. So these inequalities involve words like and or. So I'll explain that as we go through this lesson. It's a little bit different and involves actually kind of solving 2 inequalities at one time. So let's look at a vocabulary word, which is compound inequality, which means it consists of 2 special or distinct inequalities, and they're joined by the words and or the word or. Okay? So just as an example here. So if I have a compound inequality that involves and, okay, it means they can overlap. The solutions can overlap each other to form that compound inequality. So for instance here, what they're showing is that if I have part of the inequality says that x is greater than or equal to 3, and the other part says that, well, also x is less than or equal to 7, the combined solution to that, or the compound solution, is both of them, which is that x is greater than or equal to 3, and it's also got to be less than or equal to 7. Okay, so now that's for the word and, right? They overlap. Contains an overlap. If instead we're dealing with the word or, okay, we have something that looks like this, right? So it could be, for this example, the solution could be that that x, or variable, can be less than -2, or it could be greater than or equal to 1. So I end up with this, where they don't overlap, right? This one they don't overlap, and they actually go in different directions. Okay? So let's practice some and see if that makes a little bit more sense to you. Okay? So let's start with an example here. So we want to know what compound inequality represents a phrase. Okay, and then we'll graph the solutions. Well, here we say all real numbers that are greater than 1 and less than 5. So my solution has to meet both of those criteria. So when I go to graph something like that, you notice how we see the word and it's in the middle. Okay, that's important. So that means we're going to put the variable in the middle, right? Put it right there in the center. And we'll have our inequalities on both sides. Now in this case, they're both less than, okay? So some number, right, less than x, which is less than some other number. Okay, so we know that if I reread it, that my solution is that all numbers, all real numbers that are greater than 1, so my solution has to be between 1 and 5. And when I go to graph this on a number line, I'll have open dots, right, at 1 and 5, and my graph will actually be in between them, okay? It'll be in between the 2 of them. So it's graphed in the middle. Okay, so that's graphing a compound inequality with the word and. Okay, what if I have one that says or? So here we have all real numbers that are less than 10 or greater than 15. Okay, so it separates, right? And it means the shading goes, when I have or, means the shading goes in opposite directions, right? My shading goes in opposite directions. So we're going to rewrite this, right? We're going to show this time with two separate inequalities. And I could have actually done the same thing on the last one. It's just a little bit more concise with the and to combine it into one. So if I have an or, though, I'm going to have two separate inequalities. One that says my solutions have to be less than 10, right? Less than 10, okay? Or, right, just like that, greater than 15. So that's what I end up with. So now I'm going to make a number line that encompasses these two numbers. And again, because they're less than and greater than signs, they're going to be open circles. And now I'm going to shade in the opposite directions. Okay, and then and on these with ors, I can actually go back and use the direction of my inequality to help me. So notice my inequality is pointing to the left. So for this first one, I'll shade to the left. And in the second one, I'll shade to the right. Okay. Good job. Okay. So let's go ahead and solve an inequality that has the words and in it. So here we have, what are the solutions to this inequality, this compound inequality, and then we're going to graph those solutions. So this might look a little tricky to you, okay? It's like having almost two equal signs, okay? So whatever I do has to be done on all sides, right? So let's show what that's going to look like. So it says to solve an and inequality, we have to isolate the variable in the middle, okay? Whatever we do to one side, we have to do each side, right? Each side of the compound inequality. Not just one, but both. And it will look like this. So if I subtract 2, right, I'm trying to eliminate this value right here, right? Because I want to get my variable all alone. So I'm going to have to subtract 2, okay? And if I subtract 2 here, I've got to subtract 2 from the other side of this inequality and from the other side of this inequality. So let's do our math and see what we end up with. So on the left, I get -4. My x stays in the middle. And on the right, I end up with 3. So now I'm going to graph this. Now pay attention, right? Here I'm going to have an open circle. And for this one, I'll have a closed circle. So let's draw our number line. We'll put an open circle at -4, the closed circle at 3. And remember the x, the solutions are in between that. So I'll shade in between. Okay, so hopefully this is starting to make a little bit sense to you as we go through this. I'm going to let you work on this example on your own. This is kind of an extra example, just so you can we can gradually release it back to you and you can practice it a little bit and see how you do or where you make mistakes. So go ahead and pause the video and I'll come back and we'll look at our answer. Okay, so let's see what you got. Okay, remember we're isolating the variables, so I'll show you how we're doing that. We're adding 5 in this case, right? Because originally it's being subtracted from the x, so we want to get rid of it. Now I'll do my math. And what I end up with is 2 closed circles graphed between. Okay, good work. Okay, so let's do one where we're solving an or. Okay, now in this case, notice I have 2 separate inequalities this time. So this is the one where I'm going to be solving 2 separate ones. Okay, so I'll just split them out. I'll include my or. I'm going to still keep that with me, but I'll do them each individually now. So I'll do the one on the left. Okay, and you know how to solve, so I won't spend a lot of time on that. So here's the solution that we get. So now I'll do the one on the right. Okay, subtract 2 from both sides and finish it off. Okay, now I still like to when I get to this point, bring my or down. Okay, it's either or for my solutions. So now let's graph it. So the first one, I'm going to have an open circle at -1. The second one, I'll have an open circle at 2. And again, I can now make use of the direction of my inequality symbol. And I'm going to graph in opposite directions. And that's really all that has to be done when you're dealing with compound inequalities. Okay, you're kind of solving two separate inequalities at once. Okay, so good job. And again, bring questions that you have to me, and we'll work through them.